Hello and welcome back to Steaming with Steve. Today we're going to keep going on with our binary numbers. We're going to go through how binary multiplication works in our system. So let's jump on in. What you should see with this is pretty simple. It's actually a lot easier than adding or subtracting. Basically, you either have it or you don't. So what happens is, if you look here carefully, you've got 10-10. So there's a 1 here, so you get a 10-10. There's a 1 here, so you have a 10-10. There's a 0 here, so you don't have it. And then at the end, you have a 10-10. Now you got to make sure you fill in the blanks. Usually I just use crosses, so then it makes it a bit easier. Crosses mean X's, but it just means the decimal point place, and then you just go through each column and add them together. So there's a nice simple algorithm that happens behind that. So hopefully that's giving you some insight. Let's have a go. So let's think about how we actually multiply normally. So if we had 47 times 24, just pause the video, see if you remember. Cool. So what you should see here is you do the first step, is you put in the zeros based on the columns. So this first row here is the ones column. This is the tens column, so you got to jam a 0. If you had 3-digit numbers, you would put another line and then another 0, 0. Then you go through the process. So 4 times 7 is 28. Carry the 2. Then you do 4 times 4, which gives you 16. Add on the 2, and then you got 18. And then you go down to the next row, cross that all out, and then repeat the steps again. So 2 times 7 is 14, so you put a 4, carry the 1. 2 times 4 is 8, carry the 1, add on the 1, and you get 9. And then once you finish that, you simply just add the numbers together. So 8 plus 0, 8 plus 4, 1 plus 9, which gives you that. Have a go and see if you can write out a multiplying algorithm in pseudocode. So just pause the video and see how you go. So just a normal multiplying algorithm. This is a really neat test to see if you remember how to do pseudocode. Cool. So the first step is we write the function name. So begin multiply two numbers. So num1 is equal to 4, 7, and I'm going to store that in an array. So then the 4's and then the 7 is a separate column. Num2 is 24 or 2, 4. Then we have the power column, the variable, and then the output at the end of what needs to happen. We're then going to go for I is equal to 1 to the size of number 1, and we're going to increase that by 1. Then we're going to have a carry variable that allows us to carry across as we're going inside each column. Then we're going to go iterate through the second value, which is the j value, which is num2, and you're going to iterate through each part. So you're going to do the ones column and the tens column, and then the ones and the tens in the next one. So the result is equal to num1 at position I times num2 at position j. And then if the result mod 10 is greater than 9, we've got to do a carry case, don't we? Because there's going to be extra. So we're going to do the output is now equal to the output plus the carry that was given to us before, plus the power, plus the result mod 10 times the power. And then the carry that's left over is equal to the result integer divided by 10, which chops off the tail. Else, it's pretty simple. We just do the output is now equal to the output that was given, plus the carry times the power, plus the result mod 10 times the power. Carry is equal to 0. End the if. Power is now equal to power times 10, because we want to go to the tens column inside that inner loop. And then we want to do next I, and then power is equal, next j should be there. Power is equal to 1. And then next I there, and then return the output and multiply two numbers. Now, would you be expected to do that in an exam? Absolutely not. But hopefully you should be able to understand the pieces of the puzzle as I was talking through that. So your turn. Have a go and see if you can do 63 times 47 and follow the algorithm. Cool. So the first thing is you should write the 0 in. Then you go through and multiply numbers. So 3 times 7 gave you 21. So you put a 1. Then carry the 2, so we carry the excess. Then we repeat the steps again, so we do 6 times 7, which gives us 42, plus the 2, which gives us 44. Then we go 4 times 3, which is 12, so we put a 2, carry the 1. 4 times 6 is 24, plus the 1 gives us 25. We then, once we've exhausted all that, we then add the columns together, and we get 2961. What about binary? Now, this is pretty hard. It's exactly the same. It's really not different at all. So what you need to know is remember the rules. So 0 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 0 is equal to 0. And then 1 times 1 equals 1. And you may have heard me talk about this before. Multiply is very similar to AND. Or not even similar, it is AND if you look at it carefully. So the operation of multiplying in binary numbers actually outputs the AND condition. So this Boolean operation is exactly the same as AND when you do multiply. So how do you multiply in binary? Really simple. Basically, whatever's up the top will either be repeated or a whole heap of zeros. That's basically it for each row. So the first step is to work out what column that you're dealing with and draw out the lines. So if you've got 4 numbers or 4 bits, you will have to have 4 separate boxes before you add at the bottom with the total. So the first step is you put X's in based off the columns. So in the first box here, there is nothing that needs to go. Then we put an X here to represent a 0 needs to go there. Then we put 2 X's underneath that, and then 3 X's. So we're up to this. Now the reason why I use X's instead of zeros is it helps your eyes because there's a lot of things going on in here and it makes it a bit easier to deal with. Then you basically either have it or you don't. So it's either going to be the number, which is I've highlighted in blue, or it's going to be 0. So for example, 0 times 1011 is just 0. 1 times 1011 is 1011. 0 times that isn't anything, so you put zeros in, and the last one is 1011. Once you've done that, then you just filter through the columns, add them together as so, and then you have them all added together and you get that number. And then you can always check it. So 11 times 10 in decimal is 110, and then check your number at the end. Is it 110? If it is, you've done your job. There's a cool video there that you can have a look at if that didn't make sense, but hopefully that worked. So have a go now, pause the video, see if you can do this. Awesome. So what you should have found is you got an X there, then you went through X, 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 X. That pretty much is the same every single time. You don't have that, you don't have that, you do have that, you do have that. That's pretty much all it is. And then just follow through the columns and add them together. And that's what it is. Then you can always check 15 times 12 in your calculator, see if it equals 180, and then see if that number down the bottom, which it definitely does. Cool, so your turn, have a go at that. Pause the video, see if you can follow the steps. Cool, so what you should find based on the X's, so XX, XXXX, then you put numbers in the columns, and then that's pretty much it. So you do have the first one, second one, don't have the third one, do have the last one. And see how this is just like a good old algorithm? And then lastly, you add it all together and you get that. So then you can check it, 13 times 11 equals 143, which is what that number is down the bottom in binary. Have a go at that, pause the video. So this one's a little bit different because there's only 3 bits. There's only 3 boxes above the total at the bottom. So that's why we would only have an X and then an XX. Then we go through it. You have the first one, you don't have the middle one, and you do have the last one, and then just go through and add together. There is also a concept called the shift add multiplier, which is in the curriculum. Basically what happens is what we've done there. So you've got the 4-bit adder here, the multiplier on the end here, and what happens is this is the algorithm that happens behind inside the controller. So notice that there's 8 bits and then the carry column here as well, and then you're adding on the multiplicand on the end here. Now this algorithm took a while to animate. Hopefully you get your head around how that sort of looks. Not many questions in the exam for this, but just so that you've seen it, it does help. So the 9th bit, like I said, is the carry on the addition. So the algorithm here is basically you start, you test the multiplier. If it is equal to a 1, you're going to do something different. So you're going to add the multiplicand to the product, like what we just did there. So the blue number gets added on, and then shift across to the multiplicand to the left. If the multiplier is equal to 0, we just put zeros in. We don't need to do anything. So that number doesn't need to be added in. Now notice that the multiplier, the number that we had in the blue, was the thing that kept getting replicated each time. Then we shift the register 1 to the right, and then we basically go through 32 bits, and at the end we have our number done. So that's a little bit of a flow chart to show how this sort of works. And then that loops in on itself 32 bits, and if that's yes, you exit. So let's try again with 11 times 13, which is what we just did before. So we know that 11 is 1011 and then 13 is 1101. So the answer should be 143 or 1001111 at the end. Now just bear with me, this is a little bit more complex, but if you understand this, the algorithm is a lot easier. So in here is what we're going to put is the 1101. So if we go back here, 1101 is the 13. So that is the thing that's going to be timesing or the multiplicand of the multiplier. And the multiplier goes up in the top right here. So 1011. We're then just going to follow an algorithm. So note M is the last bit that you've been dealing with, and then I'm going to color that in orange. So there's what's inside the top there. So there's the 9 separate bits with 1011. So that's the initial products of the register. Where that dotted line is represents where we're currently focused on as we're shifting through all these. So the first bit is we're going to look at that 1. If it's a 1, means that we have to do the multiplicand. So we're going to do it. So we're going to have the multiplicand. We've got 1101. And then it's pretty simple. You just add the things together. So you get 1, 1, 0, 1, 1, 0, 1, 1. Cool. So hopefully that should look the same. It's very much color coded. So if we have it, we add it in. If we don't, we just put zeros in. Now this is where it gets a little bit different. We're going to do a shift now and shift all those bits across. So this is what we call a bit shift. And what happens is they're doing a bit shift to the right, and those values that have not been used get basically erased on the end there. And basically what's happened is that bit has been evaluated and then it's been jammed in at the top here, which is pretty cool. The next bit then is we look at the next value, which is that 1. Now because it's a 1, we add it on. And because everything's been shifted across, this is then the 2's column or the next column across. Now we just go through and do the simple process of adding. So 1 plus 0 gives you 1, gives you 0, gives you 1, gives you 1, gives you 1, 1, 0, carry the 1, 0, carry the 1, 1. So now we have this extra shift bit that's happened here. So then that's been done. We're now going to shift everything across again. So then that gives us a 0. Now because that's a 0, when we're looking at that value there to evaluate if we're going to do anything, we do nothing. So we skip it. So we skip and then we do another shift and we get that. So then that value comes down. We look at the 1, we've got a 1, so we're going to have to use our multiplicand again. So we're going to put that in. So 1, 1, 0, 1. After the addition, we get 1, 1, 1, 1, 0, 0, 1, which gives us that value there. And then after our final shift across, we get our final answer of 1, 0, 0, 1, 1, 1, which is the same as 143. Cool. So there's an original version there if you want to have a play. Now there's a homework sheet that I'd encourage you to have a crack at. The more that you practice these, the easier they become. Generally speaking, you'll only need to do those your turn versions. The multiplicand shift is a bit more of an advanced concept, but if you understand it, it does make the whole process a bit easier. So that's it from me from Steam It with Steve. Hopefully you've enjoyed. If you did, please give us a like and subscribe. If you've got any questions, please put them in the comments down below. And yeah, see you next time. Adios.